Good morning, everybody. This is a presentation of finite theory and gravitomagnetism that replaces general relativity at all scales, from the solar system scale to the visible universe to the greater invisible universe. Here we see the traditional light bending experiment that was done earlier in 1919 this century, where we see that general relativity light bending prediction is twice as much as the Newtonian light bending. But I have to say that general relativity was already adapted by the perihelion precession in the first place. So it's not really a prediction, it's already adapted, so there's room for discussion over there already. The gravitational redshift, we see here a laser bouncing back and forth on the mirror starting as red is going to blue shift when the elevator goes down in altitude. So basically the general relativity's redshift refutes the special relativity's locality postulate. Regarding the black holes, we see that black holes are either singularity or wormholes in general relativity. So if there's a black hole collision, then we'll end up with another singularity, quite simply. So that's the prediction that general relativity comes with. Regarding the inflation of the universe, general relativity predicts that the universe inflates like a bread in an oven, but also it loses energy. So we don't really know what happens to this energy. It breaks the laws of the conservation of energy right there. So general relativity just fails at this scales already. So regarding finite theory and gravitomagnetism, I have to start with the measurement units of gravitomagnetism because they're much simpler than what is written in the textbook. If you simplify the measurement units, you end up with some similarities with the electric and gravitoelectric field, which is the standard gravity, the magnetic and the gravitomagnetic field, where you just add some, I call it the Kc constant here, which is a ratio of the mass and the coulomb that you need to add, or you need to multiply with or divide with to convert one with the other. But it's basically the same measurement units. There's no big difference there. So regarding the main equation that I use to convert one between the other, I use the energy density here of a photon, where we see the electric field and the gravitomagnetic, the magnetic field here equals to the Planck constant times frequency times n, where n compensates to the density of the energy, where the density of the energy really is the frequency or the gravitomagnetic field divided by the gravity permeability and the Planck constant. And the electric field and the magnetic field can be also decomposed into the Kc constant, which is the electromagnetic permeability divided by the gravity permeability, the square root of that ratio is what I call the Kc constant. And when we decompose that equation here, there's also another property, an important property that of a photon, that the electric energy density equals to the magnetic energy density. So one equals to the other. So we can simply use the middle formula, the formula at the bottom here, that the energy field, the electric field, is equals to the magnetic field times the speed of light, or the gravitoelectric field equals the gravitomagnetic field times the speed of light. So with this simple equation, we can deduce a lot of properties of the speed of light. And here we see in the middle bottom here the gravitational redshift. If we use the variable speed of light as first postulated by Einstein, and later extended by decay, we see that the frequency change of the speed of a photon is given by the following formula. So it's really a shift of speed, where a photon will always be the same speed locally, will always be c regardless. So at that point it needs to go faster, but it gains gravitomagnetic energy, which is the frequency. It gains it's a transfer of energy from the gravitomagnetic from the magnetic field to the gravitomagnetic field. So that's why we see a photon losing energy when it comes out, losing electromagnetic energy when it comes out of a gravity well, but it actually gains its speed, so it gains gravitomagnetic energy. Here we see the acceleration of the universe relative to what I call a universal core. Universal core is what will create a difference in gravitational potential, where the visible universe is traveling within. So basically, the Hubble constant is basically the delta Hubble constant is basically the delta gravitomagnetic field, quite simply. So it's a change in time, frequency. Sorry, it's a change in frequency that the universe is traveling through within a greater gravitational potential differential, like I just said. So it's very simple. And again, if we want to compute the acceleration of the universe, all we have to do is multiply the Hubble constant with the speed of light. So remember that when we have a gravitomagnetic field, we can get the gravitoelectric field very easily because one equals the other. There's an equivalence in energy density right there. So with that we can compute the delta acceleration, and we can solve the distance from the universal core, the distance of the visible universe from the universal core, and the results are the following. I have to say also that the mass density, the volume mass density of the universe equals to the mass of the universe divided by the volume, the spherical volume of the universe, which is given by solving mass using an inside the sphere equation that I'm using in my manuscript. You have to take a look at my manuscript. So by dividing the mass, that mass divided by the volume of a sphere, then you can solve the radius of the universe, the minimal and the minimal and the maximum radius of the universe, the speed of the universe, the acceleration of the universe that I already mentioned before, and the position of the universal core, which ranges from 7 times 10 to the 24th meters to 1 times 10 to the 24th meters, which is 100 million times. The radius of the universe is actually 2 times 10 to the 23 meters, which is 100 million times lesser than what the mainstream says it is. So there's a big correction right there from what the mainstream is teaching us. And it's actually quite precise. It's based on the mass density of the universe. And so the position of the universal core is actually from 10 to 30 times the size of the universe. So we're not very far away from the universal core. Regarding the Earth tides here, I'm showing using a software and multiple microgall measurements that around the planet, that there is a difference with the prediction and the measurements. So that means a gravimeter at 3 o'clock in the afternoon will not measure the same thing as a gravimeter at 6 a.m. in the morning, because the gravimeter is either perpendicular or aligned with the sun, and the prediction and the residual actually is very proportional to the derivative of the gravity prediction. So that means the residual is very consistent with the fact that the gravimeter is either perpendicular or aligned with the sun. So that means there is obviously either or a co-moving superposed gravitational framework. So that's evidence right there that there is ether. And the light bending here compared with Newton is exactly the same as predicted by general relativity, or twice what Newton predicted for the angle of the light bending. Regarding the black holes, with finite theory, black holes have a maximum mass density, so there's no singularity. And when two black holes collide, then it'll create a bigger aggregate black hole, but it's not going to be another singularity. And this was proven last year that two black holes colliding will gain in mass, in size and mass. So this is exactly what matches the observation and what Stephen Hawking was predicting as well. So this another disproof of general relativity. Using finite theory, I'm able to reverse engineer the rotation curve of pretty much all the galaxies by reverse engineering the rotation curve. I'm able to figure the maximum fudge factor that the galaxy is with. It's around 1 times 10 to the 20th. The fudge factor is around 1 times 10 to the 20th kilogram per meter. So that's how I'm able to say the maximum mass of the universe can be, and what the maximum radius of the universe can be also. So because the fudge factor of the Milky Way cannot be greater than the fudge factor of the cluster, which in turn cannot be greater than the fudge factor of the supercluster, which in turn cannot be greater than the fudge factor of the universe. So and so on. So this is how I'm able to, and you see the rotation curves are very consistent. So there's no big mystery here. Also, the co-moving framework, gravitational framework, actually says that you have the stars spinning around the core of the galaxy, but the core also itself is spinning because of its mass. This mass is so great that it's also spinning. So this is a postulate of special relativity of finite theory that says that right here we see the time dilation of the rotation curve, but you also add a spin. So the equation is very simple. You also add a spin that adds the what we've been deducing as dark matter for so long. It's just you just add a spin to the galaxy, and it solves that problem. The expansion of the universe here, we see that using the Newton or the dark red is faster at the beginning but is slowing down, where using finite theory the time contraction actually speeds up the expansion of the galaxies. So it ends up that the race is being won by finite theory here, by who reaches the greater distance faster because of the time contraction. Again, the galaxies are expanding faster and faster because of the time contraction. So that removes the need for dark energy right there. So it expands really because of the time contraction, not dark energy. The inflation of the universe here is similar to general relativity, except that the universe itself is traveling through a difference in gravitational potential. So that makes the universe expand because of the time contraction, but it also, you need to add the gravitational redshift. And what we thought that the inflation of the universe were losing its energy really is the fact that the visible universe is redshifting its electromagnetic energy and converting it into gravitomagnetic energy. So it's very simple. The universe has a speed, which would make sense, and the gravitational redshift makes it apparently losing electromagnetic energy. So regarding the gravitomagnetic field, here's a real abduction that we have been posting before. So it's really a gravitomagnetic beam that induces a gravitoelectric beam that propels Travis Walton up from the ground, and also from that abduction scene, it was said that the trees surrounding the abduction area grew faster than what was than other places. So it's really a contraction in time that speeds up, that puts the trees on fast forward and speeds up their growth. So it's by playing with gravity, you can play with time dilation and time contraction. So you can easily accelerate the growth of the trees or slow them down. Also, using a gravitomagnetic field, you can create a force field by stopping anything from reaching you. You can by dilating time, you can stop anything, even laser beam, nuclear bombs, missiles, pretty much everything from crashing on you. You can create tractor beams to freeze entire vehicles from traveling, and put them on hold and freeze everything within that vehicle. And you can also create blink drives by contracting time. You can speed up time within an artificial tunnel, and you can travel faster than the speed of light very easily without breaking the laws of general relativity. So thanks for your time. I really appreciate it. And if you have questions, please post them in the comments. Thank you.